Today, we're diving into one of the biggest puzzles in medicine. How do you find the perfect drug combination? This is the story of a single, beautiful equation that brought order to total chaos and completely changed how we fight disease.
So let's start with a really simple question that gets right to the heart of this. In medicine, when you combine two drugs, you're hoping for synergy, that magic moment where the combined effect is way, way bigger than what each drug could do on its own. But how do you actually know if you've found it?
On one hand, you have this incredible promise. Powerful drug cocktails are the reason we can treat diseases like cancer and AIDS today. But on the other hand, there was a huge problem. For more than a century, the very idea of synergy was a complete mess. You had something like 15 different definitions floating around, which, as you can imagine, created a ton of confusion.
And listen, this wasn't just some dusty academic debate. Getting this right was a trillion-dollar question for the entire drug industry, for researchers, and of course, for patients. Everybody needed one single reliable way to answer the question, is this working or not? All right, so this is where our story really pivots. We're moving from the chaos of the problem to the elegance of the solution. And it all centers on one scientist who decided to look at this whole puzzle in a completely new way.
So the old way of doing things was what you'd call bottom-up. You just collect mountains of data from experiments and then, hope a pattern would magically appear. But Dr. Ting-Chao, he totally flipped the script. He started top-down. He said, let's start with a universal law, a fundamental truth first, and then use that law to make sense of the data. It was a completely different way of thinking. To do this, he went back to the absolute basics, to a field called pharmacodynamics, or PD for short. Now this is a really important distinction. It's not about what the body does to the drug. It's all about what the drug does to the body. It's that core relationship between the dose you give someone and the effect you get back. Okay, so how on earth do you create one law that works for every drug, every cell type, every disease out there? The breakthrough, the genius of it, was to think in terms of relativity. By turning every single measurement into a simple ratio, a relative comparison, Dr. Chao basically created a universal language. All of a sudden, it didn't matter what the drug was or how it worked. Everything could be compared on the exact same scale.
And this right here, this shows you just how powerful that idea is. Now, what's so cool about this slide is the comparison. That blue line, that's the physical decay of radioactivity, a predictable, universal law of physics. The red line, that's the effect of a drug, plotted using Dr. Chao's equation. Just look at how closely they match. He found a principle in the messy, chaotic world of biology that was as fundamental as a law of physics. It's incredible.
Having a beautiful theory is one thing, but turning it into something that thousands of scientists can actually use in their labs every single day, that's a whole different challenge. And this is the story of how that theory became a tool. And let me tell you, this wasn't an overnight thing. It was a journey that took decades. It all started way back in 1983 with software for an Apple II computer. Then it evolved in the 90s for Windows, and finally, in 2005, it became the modern tool we see today, CompuSyn. This was a real, sustained effort to get this powerful idea into the hands of everyone who needed it. And you can literally see the evolution right here. On the left, that's what scientists used to work with, just dense, complicated text that was super hard to understand. And on the right, that's the modern version, a clean, clear graph generated automatically. This innovation made it possible for any researcher, not just a statistician, to do this powerful analysis. The impact was just a complete game changer. These complex synergy calculations that would have taken a scientist days to do by hand, they could now be done with unbelievable accuracy in just a few seconds. And all of this newfound speed and efficiency led to what Dr. Chao calls the econo-green revolution, a whole new way of doing research that's not just cheaper, but also a lot more ethical.
This table really breaks it down. By using the theory to design smarter experiments from the start, the amount of resources you need just plummets. In the lab, you might only need 16 data points. For animal studies or even human trials, just 10. And that means you're using less material, you're using far fewer animals, and you're designing smaller, faster, and cheaper clinical trials.
And the word universal just keeps coming up, because this method is staggering in its scope. It's not just for drugs. It works for chemicals, radiation, even viruses. You can apply it in a petri dish, in animal studies, or in full-blown clinical trials. And maybe most importantly, it works no matter how the drugs actually do their job inside the body.
So, did it work? Did the world catch on? Well, here's a number for you. By late 2025, Dr. Chao's core papers on this theory had been cited by other scientists over 42,000 times. That number isn't just a number. It's a direct measurement of how absolutely essential this work became for researchers all over the globe.
But the journey to becoming a scientific truth is rarely a straight line. This final chapter is about the human story, the story of perseverance behind all the science.
You'd think an idea this powerful would have been instantly accepted, right? Well, not so much. Dr. Chao himself says that he had a really hard time getting these theoretical papers published. In fact, a lot of this groundbreaking work, he developed it basically as a hobby, in his spare time, or on his commute.
But here's the thing. While some journals and reviewers were skeptical, the absolute top minds in the field, they got it. Dr. Chao's work was actually praised by multiple Nobel Prize winners, people who could see the profound breakthrough he had made.
And that really brings us to this final, powerful idea from the physicist Max Planck. It's this perfect reminder that huge, revolutionary ideas in science often win out not by arguing, but just by enduring. They succeed because a whole new generation grows up with these new tools, and to them, it's not some controversial new theory. It's just the truth.